In Lesson 6.2, students see you do a demonstration in which you add vinegar to baking soda. The question is it a chemical reaction? And if it is, how can you control the amount of products produced in a chemical reaction? And the big science concepts covered are, in a chemical reaction, the amount of reactants affects the amount of products, and using a lot more of any one reactant won't necessarily produce a lot more products because both reactants are needed to make the products in a chemical reaction. So the first thing you do is you add vinegar to baking soda and ask students whether this is a chemical reaction. Students will probably say yes because they're used to seeing vinegar in baking soda as a chemical reaction, but also you should press them that how do they know? The idea is that there's something new produced, that you added a liquid to a solid and you saw bubbling, a gas was produced. And that's evidence that a chemical reaction took place because something new was produced. So for this vinegar and baking soda reaction, you'll use 1 drop of detergent in the vinegar and then pour the vinegar into a graduated cylinder that already has a half teaspoon of baking soda in it. Let's see. So here we're adding 1 drop of detergent to the vinegar and placing 1/2 teaspoon of baking soda into a graduated cylinder that's 50 milliliters. And we're going to pour that vinegar with the detergent into the baking soda. And you get a lot of foam. The advantage of using the detergent is that the foam lasts longer and you get an idea of the amount of CO2 that was produced. So now the question is, can students add vinegar and baking soda to a graduated cylinder with 1 drop of detergent solution and make the foam only reach the top but not overflow? You can give them a couple of tries to see if they can come up with the right amount of vinegar to baking soda to produce a foam that goes to the top but doesn't overflow. And at this point, you can look at the equation for the vinegar and baking soda reaction. Vinegar is acetic acid, and the baking soda is sodium bicarbonate. And when those react, you get a salt called sodium acetate, water, and CO2. So if you showed this equation to students and asked them, what do they notice when they react vinegar and baking soda? They notice that there's a gas, and you can ask them what that gas is. And if they look at the equation, it's carbon dioxide. Another use of this chemical equation is that students can see that it's balanced. You can use it to practice the idea that whatever is on the left side of the equation, the reactants, ends up on the right side. And you have the same number and type of atoms on the left as you do on the right. Students can count up the atoms by looking at the formula. You can help them remember how to use the subscripts, and they can see that there are 2 carbons here. And how many carbons here? This little 3, you have to remind them, doesn't apply to that carbon. It only applies to the one right next to it, that O. So there's 1 carbon and 2 carbons here. So it's a total of 3 carbons on the left side. So on the reactant side, they would put a 3 here. And on the product side, they would find the carbons here. And there's C2, so there's 2 carbons here and 1 here. Again, reminding them that that 2 doesn't apply to the carbon. It only applies to the one that it's right next to, the oxygen. And you would do that for each of the atoms, and students would find that there's the same number and type of atoms in the reactants as there are in the products. So mass is conserved. If you're in an NGSS state, there's a performance expectation, MSPS 1.5, which says, develop and use a model to describe how the total number of atoms does not change in a chemical reaction, and thus mass is conserved. Lesson 6.2 relates to this performance expectation because it's exactly what students do. They first see the phenomena, then they work with it themselves, and then look at a chemical equation that represents the reaction that they worked with, and they see that there's the same number and type of atoms on the left as there are on the right. That means that mass is conserved. So students develop a model to describe unobservable mechanisms. In this case, the model would be the equation for the chemical reaction. Students can use that to understand what's happening down at the atomic level. For disciplinary core ideas, substances react chemically in characteristic ways. Well, they see that vinegar and baking soda react in a way that produces a gas. They also see that the number and type of atoms is conserved and that the mass doesn't change. for cross-cutting concepts, this idea that matter is conserved because the atoms are conserved in physical and chemical processes. In this case, it's a chemical process, a chemical reaction. So thanks for watching, and good luck with the lesson.